So open up your PDF or print out that booklet that I gave you, so that way you don't have to write all of this by hand and you have some of it already ready for you to go and it'll be nice and organized. A linear equation. The linear equations most likely look in these two forms. It's either going to be y equals mx plus b. That's the most common one. This is the slope-intercept form. The second most common form for a linear equation is standard form. I know that in this class we didn't focus a whole lot on standard form, but that's just because all you had to do is move this x to the other side and then it's in standard form. So it's really not that hard to get standard form. In the math classes that are after Algebra 1, standard form is really important and you will use it pretty often. Quadratic equations. Quadratic equations are, remember, they're just the one step above linear, just one little piece more complicated. So the quadratic standard equation is going to look almost like this linear equation with just a little thing different. It's going to be y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c is the standard form quadratic equation. Okay, so look at this and look at this. This one has mx, so that's something times x plus b. This one has an x with something multiplying it plus c. If you look at b and compare it to c, this and this have no x. These both have just an x to a power of 1. And the only difference is this one has an x squared. So that's because, make sure you write this down, this has a degree of 2, and the linear equation has a degree of 1. And just because now that we have an example, the degree comes from, you look at your variable, which is going to be an x or y or z. You look at your variable, which is x, and that power for the linear equation is 1. The power for the quadratic equation is 2. And that's how you can tell them apart. If it has a power of 2, it's quadratic every single time, as long as the highest power is 2. If there was a power of 3 and a power of 2, that's going to make it something different. All right, we got one more bullet point here. So this is actually the standard form of a quadratic equation. So that means that the second one is not going to be the standard form. It's going to be called the vertex form. Y equals a x minus h squared plus k. Whenever you have this h and k, these are going to help us find the vertex, and we'll talk about the vertex in some other day's lesson. So the most important thing about these two equations for quadratic is they have a squared somewhere so that that squared applies to an x. If the y was squared, that makes a different type of equation, which you'll learn about in pre-calculus. Let's go and talk about the linear parent function. The linear parent function. The parent functions are the ones that are the most basic. I mean, we're already basic because we're linear, but if we go the most basic linear thing, what is the only thing you need to have a line? You need a y, and you need a variable. Y equals x is the most basic equation we can have. And to graph this equation, whatever x is, y is going to be the same thing. So let me zoom in. In this equation for y equals x, whatever number you pick for x, y needs to be the same exact thing. If you pick 2 for x, y is going to be the same thing. It's going to be 2. If you pick negative 2 for x, y is going to be negative 2. So no matter what, whatever you pick for x, y will be exactly the same. So it makes this line, this special line, this memorable line, and this line goes like that. And it happens at a 45-degree angle, which is directly halfway between vertical and horizontal. So y equals x is going to be called, in geometry you'll learn this term, but it bisects the y-axis and the x-axis. It's called a bisector. So if that's the most basic linear parent function, what would be the most basic quadratic function? Well, we're going to need two variables, so we need a y and we need an x. And what is the only requirement that differentiates a quadratic from a linear? It's the power of 2, the degree of 2. That's why I told you about that at the start of class. So y equals x squared is the parent function of a quadratic. So all we have to do is put random numbers for x, square it, and then we're going to put that value for y. So let me just go ahead and make a table right here. X, y equals x squared. You get to pick random numbers, any number you want for x. 0, 1, 2. But then let's also put some negative numbers. -2, -1. If I'm going to do 0 for x, and then I'm going to square it, I'm going to get 0. If I put 1 for x, and then I square it, I get 1. 2 for x, squared, 4. -2. Okay, so here's some place where people often make mistakes. When you plug in a -2, it's going into the equation for x. And what's happening to x? X is being squared. So you have to put this -2 together in a parentheses for x. In a parentheses, okay? The parentheses is the part that people forget. If you're plugging in a negative number into a power, into something that has an exponent, you need to use a parentheses when you're plugging that number in around that negative number, or else your calculator is going to make a mistake, or you're going to make a mistake with the negative sign. So -2 squared means we have -2 times -2, and two negatives make a +4. Now let's do the last one, which is -1 squared. -1 times -1 is going to make +1. I have a good amount of points, so now let's just put these on this graph. 0 goes with 0. 1 goes with 1. 2 goes with 4. -2 goes with +4. -2 goes with +4. -1 gave us a +1. So look at this graph. Boom, boop, 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 boop. And let's connect it with, not a line, but connect it with a curved line. Or just a curve. And we get this little shape. Hopefully yours looks better. If it doesn't, I'm okay with that. So the most important thing about quadratics are they have a power of 2. And when you're going to graph a quadratic, you need some positive values and some negative values in order to get the best picture. Okay, so the rule isn't actually that you need positive and negative, but it really just depends on where that picture is going to be centered, and we'll talk about the centers in a different video. In your booklet, I want you to graph these equations for me. Alright? So go ahead and pause your video, graph these two equations, just like normal. And then when you're done, I'm going to show you how to graph this one. Alright, let's go ahead and graph y equals 2x squared. For y equals 2x squared, and for any graph, if you're going to graph anything, you need to make a table. The table is what tells you where to put your dots. So let's just make a little t-chart. X, y. You might need some more space off of your page. I don't know, maybe right on the back of your page if you printed it out. So we need x and y, and we're doing y equals 2x squared. So let's go ahead and pick some x's. 0, 1, 2. These are the easiest numbers to pick, at least for now, because they're the smallest numbers that we can have. So 2 times x, which is 0, and x is being squared. We're not squaring everything, we're only squaring the number we put for x, which is 0. So that's 2 times 0, which makes 0. Let's do this next one. 1 for x means 2 times 1 squared. You're going to square the 1, multiply by 2, and that makes 2. 2 times whatever we plug in for x, and we're going to square that number. That's 2 times 2 squared. 2 squared is 4. That's 2 times 4, which makes 8. And I don't know if I can even graph that one. So we have 0, 0, 1, 2, 2, 8. It's going to be like up there. It's going to be off your graph. Unless you change your scale, make sure that number is off of your graph. But this does not look like that picture that I showed you earlier. Every quadratic is going to look like this shape or this shape. It's either going to be a U or it's going to be an N. Every single quadratic looks like one of those two shapes. But since right now we only have that part, let's plug in some other numbers from this side of the graph to see what this shape is going to look like on the left side. Real quick, x, y equals 2x squared. And I'll do a -1 and -2, and hopefully that's enough. 2 times whatever we plug in for x, which is -1 squared. -1 squared is 1 times 2 is 2. 2 times -2 squared. -2 squared is 4 times 2 is 8. So -1 goes with 2. -2 goes with 8. It should be exactly the same height as that other dot because over here we also got an 8. So now we can connect this side of the graph and see that they look the same. They make a U. And if you drew this to scale, this U is actually going to be skinnier than the one that was above it, than the parent function. Okay, with that example out of the way, let me just summarize what we did. In order to graph an equation, you need a table. In the table, you can pick any numbers you want. The easiest ones to pick are 0, 1, and 2. For lines, that'll be enough. But for a quadratic, half of the graph is going to look different than the other half of the graph. It's not just a straight line and done. It's a curve. So to find that curve, you're going to have to plug in more points on the opposite direction. So once you kind of have half of the shape's picture, if you plug in numbers that are continuing in the other direction, you should get the other half of the shape. After you graph those, I just have a few more for you to do as a part of our examples, and then you'll get to do your regular questions. Just a few more questions after this. I want you to graph y equals -x squared Please graph for me y equals -x squared, y equals -x squared plus 2, and y equals 1/2 of x squared. These are all important graphs that'll teach you the basic shapes and what's going to happen whenever you multiply by a negative, whenever you add numbers to it and it's negative, and whenever you multiply by a fraction. These are all important things to know. I don't expect you to memorize it all in the first try, so that's why we got to practice right here and after this video too. Okay, so pause the video and try these on your own. Okay, the last thing I'm showing you in this video is the general picture. This graph is going to have the origin included, and then it's going to have -1, -1. It's going to have +1, -1. It should have -2, +4. It should have -2, -4, and it should have +2, -4. When you're making this table, when you plug in -2, the negative is not on x. The negative is outside of x. This is going for x. So that's a -2 right where x is, and that's being squared. So when you do this, that negative on the outside stays. This negative on the inside of the parentheses is going to disappear and just be a 4, so we have -4. That's why this works. That's why I told you, you need to pay attention to that negative sign and put a parentheses only around what you're plugging in for x. That negative was outside of x. Okay, so the general picture for this one would be like this. This one will look like this. And this one should look like that. I want you to make sure that you have the tables for these and you can do these. If you don't understand, ask me a question or look for my other videos from last year at this time.